Hey, all you cool cats in the pathway. Mr. Klein here. I'm going to talk a little bit about how you run the simulation for your project. Before you can run your simulation, you first need to do some research about your response variable and your explanatory variable. So I'm going to do an example. And in my example, I have chosen Ebola as my infectious disease. So the first thing I was looking for is what is something that Ebola affects? And by doing a little bit of research and by asking my science teacher, I found that it affects white blood cells. A little more research led me to conclude that it lowers the level of white blood cells. Now, this is not true for all diseases. Some diseases are actually going to elevate your white blood cell count as your immune system fights the infection, but in this case, it lowers them. So my next question was, since white blood cells is going to be my response variable, what is a normal range for them? And I found with just a little bit of research that a normal range would be from 4,500 to 11,000 white blood cells per microliter of blood. Cool. So what next? Next, we need to find a treatment for the infectious disease. I did a little bit of research, and it eventually led me here that there are no official antiviral drugs that have been approved by the US Food and Drug Administration, but there are some tests going on, and there is sort of like an open investigation of this drug made by Regeneron, which maybe you've heard of because they're making COVID antiviral drugs. And this drug is called REGN-EB3. So I did just a little more research on that and discovered that this is a variety of drug called a monoclonal antibody, and that there are 3 different antibodies that are being supplied to Ebola victims, and that the preliminary results are that it seems to be helpful in elevating their white blood cells. So what do I do with this? I say, my explanatory variable is whether you receive this monoclonal antibody or not, which means that one level of treatment will be the REGN-EB3, the drug with the antibodies, and the other level of treatment will be the placebo. Really important that you get these 4 things filled out right, because they will drive everything that you do after this in the project. Next thing we need to do is come up with numbers. Now, the first number that we're going to need is the mean of the response variable. And so here's the logic that I used to work out the mean. I'm going to pull up my graph right here. So based on my research, scoot you over a little bit. White blood cell counts work like this. Anything between 4,500 and 11,000 is normal. So I decided, and I don't know if this is true, but it's a reasonable assumption, that we are looking at a normal curve and that this should be 3 standard deviations below the mean and 3 standard deviations above, so that 99.7%, basically all of our data will fall between them. And if that's the case, then the mean is going to be right here. And the mean would just be equal to adding the 2 ends of my interval that I found on the internet together and dividing by 2, and that gave me 7,750. Now keep in mind that this is for a healthy adult. And in my experiment, everybody's got Ebola. So they are definitely not healthy, right? So what I decided to do is I said, since we know Ebola lowers white blood cell counts, let's assume the mean white blood cell count of people with Ebola is only 3,000. And I made that number up, but I picked it because it is below the normal range, and I know how much below like the mean that I want it is. Okay. So the next thing that I need to do is figure out the standard deviation of the population. I did that by taking the difference between the 1,100 and the 4,500 and dividing by 6. Now, if that seems abstract to you, look at the picture again. we know that each one of these, 1, 2, 3, 4, 5, 6 intervals is one standard deviation. So if I wanted to find the width of any interval, what I would do is say that that standard deviation is the difference between 1100 and 4500, the two ends of my normal range, divided up into 6 parts. And when I did that, I got 1083. I rounded it off. A whole number is just easier to work with here. Okay, so that's where I got the standard deviation. Now, that leads us to the treatment effects. Treatment number 1 was the actual drug. My assumption is that the actual drug is going to return the body's immune system to normal. So I want to take this mean that I set at 3,000 and I want to boost it back to what would be normal, back to 7,700. So that's how I came up with this number. This is saying that in my simulation, the drug will boost everybody's immune system by 4,750 white blood cells per microliter. Finally, I decided that since I believe the placebo effect is a real thing, that even the people that receive the placebo are going to get a little bit better. And so I decided that I'm going to add 1,000 to them. Okay. So, and that was a number that I made up. I could have done 500 or 1,500 or whatever. Okay, so that's how I came up with these 4 numbers. You're going to have to come up with the same 4 numbers for your study. Now let me show you the simulations. I'm going to show you first an OK simulation, and then I'm going to show you a quality simulation. So an OK simulation would look like this. For the before, we had decided that the mean was 3,000. So I'm going to make everybody have a white blood cell count of 3,000. Every single person in the study. By the way, the names of the people in my study might look familiar to you. The next thing I'm going to do is assign a treatment effect. Now you'll notice that each one of my subjects here has received a treatment. Half of them are getting the drug, half of them are getting a placebo. The treatment effect is going to depend on what is in this treatment column. So anyone that got the treatment, they are going to go up by 4,750. That is the number that I had selected right here. Oh. So let me copy that through the rest of these cells until we get, let's see, Ava, you're the last one that's going to get that bounce. Paste. Starting at, oh, Ava, I want to give that to you too. Starting at Jack here, where he's getting the placebo, so he's only getting a 1,000 bounce. That's going to be his treatment effect. The big idea here is that you set different effects for the different treatments, and then what the subject gets will depend on that. Now, the next thing is randomness. We know that randomness rules our lives, and the same thing doesn't happen to everybody. So in this place, we are going to randomize. And the way that you are going to randomize is that you're going to use a normal variable. We know how to use that formula. The mean is going to be 0, meaning that some of us are going to get extra white blood cells by randomness, and some of us are going to get fewer white blood cells by randomness. The standard deviation will be the number that you selected here. So I selected 1,083 as my standard deviation. Therefore, that's what I need to put in this position. Now, when I type that in, I'm going to get a number that has a decimal place on it. And that does not make a whole lot of sense, right? Because you can't have part of a white blood cell. So the way to fix that is pretty simple. What you do is you type another formula called round. And look carefully here. See those highlighted spaces for the, or I should say, highlighted parentheses here and here? That shows that round is rounding what's inside those parentheses, which is my random number. So now I'm going to get a whole number, and I can copy that all the way down my column. And that will lead me to the after. So a person's after, in this case, is going to be the number of white blood cells they had before, plus their treatment effect, plus the randomness that occurred. So there's our number. Ooh, it's suggesting an autofill. Don't mind if I do. All right, so there are our numbers. This is, and it's an okay simulation, but it's not a great simulation. So let me show you what you're going to do if you want to go on to do a high quality simulation. Oh, and actually before I do that, one thing that's super annoying about Google Sheets is that if I remember that every time you edit, you're going to get a whole new set of numbers, right? We really don't want that to happen. So what we want you to do is leave this simulation here and then make a copy of it. And the way you make a copy of it is not by duplicating, but by clicking in the upper left-hand corner, copying each cell. I just hit a Control Copy. And then you're going to go to Data Copy here, and you're going to paste. But you're going to do a special paste of format of values only. Once again, values only. Now, when you do values only, it's not going to look pretty anymore, but the benefit is going to be that it's going to get rid of all the formulas, which means that these will be stable numbers. And when you do your pivot table, you will use these data right here. Don't use these because they are going to keep on changing. All right, so with that in mind, let's move to the last piece, which is a quality simulation. Now, a quality simulation is going to do two things. In an OK simulation, we're just looking at the counts afterwards. That's all we're studying. In a quality simulation, you're going to look at the change. So you're going to see from before to after, how much did it change? That's the first thing that's different. The second thing is that there was an assumption we made in the OK simulation that was bad. That assumption was in this column. It was that everybody began with the same white blood cell count. And that's not really true, right? In the real world, there is variation. So what you're going to do for a quality simulation is that for the before, you're going to use a normal random variable. So norm inv rand with a mean of 3,000 this time. So in the last example, I just made them all 3,000. Here, I'm going to make them average 3,000, but I'm going to give them a standard deviation of whatever I had chosen before, 1,083. So I'm going to punch that in. Now notice that when I do that, once again, I get all these decimal places. So I'm going to go round. Now I get a nice rounded answer. I'm going to copy it and I'm going to paste that on down. Keep in mind that the before does not depend on whether you got the placebo or the drug because, well, you haven't gotten it yet. It couldn't have had any impact on you. All right. So there's our before. We've got our after already because I left the rest of the data in here. For your change, you're going to say, all right, here's the after. There's the before. How much did I change? And then we're going to copy that data down. And the stuff that's in red here, that's what you're going to end up analyzing. Okay, so I have shown you my simulation. I want you to keep in mind that the principles of your simulation will be the same, but the actual exact steps that you take might vary depending on what your experiment is. Okay. Bye-bye.